Welcome back to the Enterprise Security Seminar. Today we're going to cover Chapter 6 in the textbook, which is entitled Securing the Network and Environment. Now in Chapter 5 we spent a lot of time looking at software, looking at how we can secure the operating system, and then more specifically how we can protect different programs, applications, or server roles that might be running on our computers. Today, we're going to look at a different aspect of network security. The chapter is divided into 5 sections, and the first one deals with physical and network security. So we're going to cover a lot of physical things that you can do to protect your environment. The second area of information here in Chapter 6 is understanding something called business continuity planning. This is also referred to as disaster recovery. And what you're trying to do here is anticipate things that could happen that could disrupt business and then plan for those events so that when they happen, you're not just caught unawares and don't really have a plan to respond to these. A lot of times you'll see that this is abbreviated Business Continuity Planning, BCP, or Disaster Recovery Planning, DRP. Either one of these models involves a task called risk assessment. This is a process that, again, you're going to be going through in your semester project. What you do with the risk assessment is you evaluate the risk of either sabotage, physical threat, that sort of thing. And you assess how much that outage would cost, and then look at mitigation strategies and how much those would cost. And then together with this information, you'll sit down with management and decide what you want to do in terms of preparing for this and just to what extent you want to go to anticipate some of these and be ready for them. The third section of this chapter deals with policy, standards, and guidelines. And many new network administrators don't want to deal with this at all. They kind of consider this paperwork and they want to mess around with physical devices or operating systems. Policies are really important though, and you can't just ignore them. If it's your job to manage a network, part of this is to set guidelines so that users know what they can or can't do, and then also so that your staff knows what the approved procedures are in terms of making changes or incorporating new software or that sorts of thing. There are 2 reasons that you want to make sure that you address policies within an organization. One of them is just to make sure that you document what your standard procedures and expectations are. The second thing is sort of a protection mechanism for yourself. Very often you will decide or suggest that certain policies or things should be implemented by management, and it's up to them to decide whether they want to take your advice or not. If you have documented your proposed policies and you've documented your case for adopting these policies, you've put yourself in a pretty good position if management does not follow through with your recommendations and then they're struck by some sort of an event that your policies could have either anticipated or could have really lessened the impact of that. You don't have to push these, you don't have to get all upset if management doesn't want to adopt them because that's just part of the job. But make sure that you have done your due diligence. It's a whole lot easier to defend yourself when you're in a position to say, yeah, we discussed this a year ago and you didn't want to do it. You don't want to get into a position of saying, I told you so. Actually, if you get into that situation, your documentation is going to speak for itself, so you don't actually have to say the words. But I think that this is a good thing for you to do from a couple of different aspects. The fourth area that's covered in this chapter is setting up security standards and discussing the role of the International Standards Organization document number 17799. This document is just a guideline for you, kind of a checklist of areas that you want to consider when you're setting up a security plan. There's 11 different areas that you should make sure you review, and we've only got a page and a half on this, so it's not a real big topic, but it is something that you should be exposed to. The last section, section 5 in this chapter, deals with classifying information. And this is your job as a network manager. Generally, you can take your data and kind of divide it into 3 areas. Things that should be available to the public, things that should be internal only, and things that should be restricted. Most of the time, you're going to have a pretty large segment of your data that's going to be internal only. And you want to make sure that you set up an access control to limit people so that they only have access to the data that they really should have access to. Moving into the actual chapter, we're going to look now at physical and network security. The first thing that the book talks about under physical and network security is the concept of access control. They've got a diagram that talks about a 3-layer security system. You know, in Missoula, you're not going to see a whole lot of really sophisticated access control scenarios, but you should always at least try to have your server and your data behind 2 locked doors from the outside of the building. So there should be a locked door that you have to go through to get into the building, and then another one, hopefully, to get to the server. The book stresses that you should use multiple barriers, and here in the diagram they're talking about perimeter security, a fence with a gate, then video surveillance. They've got a locked door, another door to get into the computer room, and then they've got motion detectors. They say this is a 3-layer security model, and we've got 4 or 5 different components that we're using to prevent access into the computer room. Another way that you can be a little bit more stringent with this is something called a man trap. They've got a diagram of a man trap, and this is exactly the structure that we've got in place at the jail. And this is actually for inmate security, not so much for computer security, but the idea is still the same. You have a resource, in this case the actual detention facility, that you can consider as the computer room. And then there's a guard station with a window looking into an area called a man trap. A man trap has 2 locked doors. The secure environment is on one side of the door, and then the other door is where you have your ingress and egress. The guards will open the publicly accessible side. Whoever needs access will enter into the room. Both doors are locked. You get a visual identification. And occasionally at this point, what you'll have to do is present some sort of security token or go through a biometric scan or some sort of a verification before the guards will open the interior door and let you go through. The book mentions that occasionally they'll even have scales inside the man trap so that they can weigh whoever is going through. It's not really to keep track of how much anybody weighs, but to monitor trends. And if I come in one day and weigh 10 pounds more, number one, they sure better not mention it, but it could be that I'm bringing something in, some sort of a tool or something else that is not part of what I should be doing. In terms of your network, this section discusses perimeter security, and the diagram that they've got shows the internet, which is your external area, hitting your perimeter devices, which are, in this case, the router, the firewall, the intrusion detection system. And then once you've passed through all 3 of those components, then you're inside the network. What you want to do is make sure that you've got enough authentication and safeguards so that the wrong people can't get through those layers of security and access your internal network. Once you're inside your building, you'll often want to set up what you call security zones. This is self-explanatory. Your reception area is going to be a publicly accessible area. Moving beyond that, very often businesses will require that you have an escort, or that people who are not employees are not allowed behind that area. When I was in the oil business, that's exactly what we had in place. The reception area was publicly accessible, and then anyone who was not an employee had to be badged and then escorted all the way through the building whenever they had to come back in. Same thing with the jail. I could not wander around and do anything unless I had an escort. And if I was there all day long moving from computer to computer, then I essentially had a jail employee with me at all times. The textbook shifts back and forth between physical security and then logical or network security. The diagram that they have, let's see, what section are we in? Under partitioning, shows you've got your internet coming in, stopping at your router, and we'll assume the router might incorporate some other deterrent devices. And then you see that we've got 3 separate areas. We've got an admin zone 1, production network zone 2, sales network zone 3, and then we also have an accounting network, which is further subdivided, and we've got that listed as a private network. You can do this sort of stuff with virtual LANs. You take this same concept and make sure that you implement this inside your physical building. Your accounting office probably has locked doors and that sort of thing. Most employees don't go in there. Again, it might have a reception area and then additional offices where they've got either personnel information or accounting or that sort of thing. So what they're doing in this entire section is kind of drawing parallels between network security and the physical security, and just showing you that even though it's a different implementation, the same concept exists. The next subsection is entitled Understanding Social Engineering. If you go to the back of the chapter, you'll see that they actually have an exercise where they take you through some steps of calling your company up and just seeing how far you can get with some typical social engineering ruses. They do suggest that you make sure that you've got management's permission before you go through any of these steps. I don't know that I would take it that far and actually go through this, but it's kind of an interesting thing just to consider and see what kind of exposure you assume might be in place, and then actually give it a try. Moving forward in the chapter, the next section is entitled Scanning the Environment, and this deals more with physical security. And the first thing that they mention is all of the different wireless devices that can be present inside a building. We've discussed cell phones a little bit. One component of that is text messaging or just wireless communications. If you've got Blackberries, iPhones, or Droids, or any of those that can access the internet, they don't necessarily have to go through your wireless system. They're actually connecting to a cell phone system, a cell tower somewhere. Even though it's illegal to tap into those, that certainly isn't going to stop somebody who's really trying to get information. So some companies require that you turn off all of your personal cellular devices, kind of like they do on an airplane. Or they've got signal jammers inside the building that make sure that you just can't use those devices inside there. I don't know if anybody does this in Missoula, but I know in larger corporations and larger cities that's actually kind of a standard practice. You need to keep in mind some of these wireless devices could be a security exposure. The book now discusses some physical things such as your environmental system. Sometimes, especially in larger computer centers, you're going to have special air conditioning units, special humidity devices, and you want to make sure that those things are all monitored. If one of those gets out of whack, that could affect your entire operation, and so you've got climate controls and alarms that'll go off if any of these things vary outside of whatever parameters you've established. I know at one point in the jail where the servers were located, we did have a problem with the air conditioning system, and that room got up to, I think, about 110 degrees. That was still within our specs of the server could operate under that environment, but we were just getting hammered left and right about every 30 seconds about how high the temperature was in there, so that wasn't something that went on for very long. Something that you will probably have to worry about here in Missoula is interruptions to the power system. I think I've probably mentioned that our power in Missoula tends to run kind of high. Instead of 110, 120, it's usually like 112, 122. It does run a little bit high. And in certain areas of the county or the state, you may have just poor power to where you get sags or spikes, and that's going to affect your computer equipment. Anytime you've got a drop in voltage and then it comes back, usually you get kind of a slammed with a lot of voltage when it comes back in. You need to make sure that you've got equipment, either power conditioners or UPSs, things that'll burn out first before it'll actually affect your computer equipment. Another consideration is having software on your computer equipment that if you do go to auxiliary power for more than 5 minutes or so, that your computers will take automatic action to close any applications and to initiate a shutdown. That way, if you do have an extended power outage, the computers will shut down gracefully, they'll stay down, and then you can configure the equipment so that if power does come back up, maybe you'll wait 5 minutes, you can have a 300-second delay in there, so that, because sometimes when power comes back on, it'll come back on for 10 seconds, go back on, come back on and off, and you certainly don't want to start initialization when that's still going on. But if you come back on for, let's say, a 5-minute period and you stay on, then you might consider that safe, and then you'll start your startup process again. If you have a Windows Server environment, make sure that your domain controllers are the first ones to come up. You want to make sure that Active Directory is running and is established before you bring up member servers. If you bring up member servers before Active Directory is in place, then a lot of times those servers are not going to authenticate correctly, and you're going to end up having to shut them down and restart them so that they can see the domain controllers. So go ahead and take care of this with your startup sequence. Just make sure that you allow enough time for your domain controllers to come back up and be fully functional, and then let everything else come back up in your network.